Hey chemistry students, this is Mrs. Miller, and today what we're going to be doing is we're going to be discussing the electrical nature of covalent compounds. In order to better understand these electrical natures, what you're going to need is this reference sheet. So you guys are going to be able to use this wonderful red reference sheet on a quiz or a test, and of course you're going to need it for today's activity. So on one side, you're going to see something which looks like a flow chart of determining the electrical nature of molecules, where you're going to quickly go down and you're going to check the bond types. So if all bonds are nonpolar, you have a nonpolar compound. If you have at least one polar bond that's present, what you're going to do is you're going to check the shape, and then based on the shape, you're going to be able to tell is it polar, nonpolar, or in this case over here is polar as well. On the back side of that sheet, what you're going to notice is the group number of the center atom. So it's important to realize that we're talking about the center, and we have elements from group 1, 2, 13, 14, 15, 16, and 17. And then you have the shape name. So 2-atom linear, 3-atom linear, trigonal planar, tetrahedral, pyramidal, bent, or 2-atom linear. It tells you how many bonding electrons it has. It tells you how many atoms in the shape, the cancellation if it is possible, meaning with the charges, and an example name. We're going to go ahead and do some practice problems associated with the sheet that you guys have as homework. So I'm going to do 4 of them with you, and we're going to start with practice problem 1, which is the same as number 1 on your sheet. So we're going to be starting with CH4. What we want to do first is do our structural formula, or the Lewis structure. So normally when we see CH4, we're going to assume that the C is going to go in the middle. So I'm going to do that. Next, I know that C is in group 14, so it has 4 valence electrons. I'm going to put 1, 2, 3, 4. Remember, we're going to put 1 on each side before we pair them up. And then I also need to draw in my 4 hydrogens. So I'm going to put 1 over here, 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 and here. And hydrogen is in group 1. It only has 1 valence electron. Remember, hydrogen is a weird one. It doesn't follow the octet rule. It only wants to have 2 valence electrons. So what's going to happen then is we're going to connect each of these together, and that is going to be our completed Lewis structure, because as we go around, hydrogen, we count that line as 2, happy, 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 happy. And then when we look around our carbon, we have 2, 4, 6, 8. It is also happy. Then what we're going to do here is we're going to go ahead and talk about the bond types. So we only have one type of bond, and they're all the same. So we have 4 carbon to hydrogen bonds. And what we're going to do is we want to figure out, is this polar or is this nonpolar? In order to figure out is it polar or nonpolar, you're going to need your electronegativity sheet that you guys got yesterday in class. And what we're going to do is we're going to take the higher number, which in this case is carbon. Carbon is a 2.5. We are going to go ahead and we're going to subtract our lower number, which is hydrogen, 2.1. And when we do that, that equals 0.4. And when we look at 0.4 on our bond types, we end up with a nonpolar bond. So that's what I'm looking for in this case. I don't have to do 4 calculations because they're all exactly the same. And overall, this is going to be nonpolar. The next thing that you have to do is you have to go ahead and you have to look at the sheet that we just saw on the previous slide. And that is our table that tells us about shapes. So when we look, if you look at the very top, it's going to say central atom group number. So again, the central atom here is carbon, and carbon's in group 14. So when we look at that and you go down the line, it tells you that it is tetrahedral. All right. And then last but not least, the electrical nature, what we're going to be working with here. All 4 of our bonds are nonpolar. So when we follow that flow chart down, which is the front side of that sheet, all bonds are nonpolar. So this is also going to be nonpolar. Our second example that we're going to go through is the second one on your sheet, so NH3. Again, most of the time, whatever is listed first is going to be the thing that goes in the middle. So we're going to start by writing the formula. Nitrogen is in group 15, so it's going to have 5 valence electrons. 1, 2, 3, 4, 5. And then we also have 3 hydrogens, and which is very convenient because our nitrogen wants to make 3 more bonds. So we're going to go 1, 2, 3, and then we just go ahead and we connect those with our lines. So now everyone's happy because hydrogen wants 2 and nitrogen wants 8. So when you count around, you end up with 2, 4, 6, 7, 8. Bond types. So again, we have a single bond type that we're working with, and it's just going to be here, the nitrogen and the hydrogen. So when I go to write this down, I'm going to write down 3 N to H bonds. And then what I want to do is I want to use my wonderful red reference sheet, which has the electronegativities, and I'm going to take nitrogen minus hydrogen. So I'm going to go ahead and do that, and I'm going to go 3.0, which is nitrogen's electronegativity, minus 2.1, and that equals 0.9. So when I have 0.9, I look at what type of bond do I have, and it tells me it's polar. Okay, so again, how do I go and I find the shape of this? Well, you have to use that other red reference sheet that is on 2 slides before this particular problem. One side has a flow chart, the other has a table, and you want to look at the central atom. So again, that is going to be nitrogen. So nitrogen is in group 15, and when you look under 15, it says pyramidal. So that's what we're going to write for our shape. And then last but not least, the electrical nature, the overall. So because we have 3 polar bonds here, this of course is also going to be polar. If you really want to get technical with it, you could also write down that our nitrogen is going to end up being partially negative, and our hydrogens end up being partially positive because the nitrogen is winning that tug of war. The next one we have is a little bit trickier. So if you flip to the back side of your worksheet, this is SiCl4. So the first thing we want to be able to do is we want to go ahead and start with our middle substance, which is going to be silicon. Silicon is going to be in group 14, so it's going to have 4 valence electrons. And then we're going to put 4 chlorines around it. So we have chlorine. Mine's going to go outside the box a little bit, but that's okay. And chlorine's in group 17, so it's going to have 7 valence electrons. So what we're going to do then is we're going to bond here. This chlorine right here is already happy because now it has 1, 2, 3, 4, 5, 6, 7, 8. And we're going to make all the rest of those chlorines happy as well, simply by putting a bond between them. And then just to double check around silicon, 2, 4, 6, 8, it's also going to be happy. All right, next what we're going to do is we need to calculate out the bond. Again, this one has all the same type of bonds. So when I go to write this down, it's going to be 4 SiCl bonds. Now what I have to do is I'm going to have to go and figure out the difference in electronegativity like we did yesterday in class or like we did for the previous 2. So again, we want to start with the highest value. So in this case, that's actually the chlorine. Chlorine has a higher value than silicon. So chlorine has a value of 3.0. Silicon is only 1.8. So when I end up doing that, I subtract and I get 1.2. So my 1.2, when I look on that reference sheet that tells me nonpolar, polar, and ionic, it definitely falls into the polar category, okay? Then what I want to do is I want to figure out what am I doing for shape. So again, you are looking at the central atom. Our center atom is silicon, and again, it's in group 14. So because we know it's in group 14, we use the new red reference sheet, the one from 3 slides ago, and we look at it, and what we're going to write down, again, is tetrahedral. Now here's the important part. Now we come up with the electrical nature of our molecules overall. What we need to do in this particular spot is we really need to look at all of the bonds. So if you follow your red reference sheet down, I'll do this with you, hang on. When you start at the top, it says determining the electrical nature of molecules, it says check bond type. It then says we have 2 arrows, all bonds are nonpolar or at least one bond is polar. Well, guess what? We have polar bonds. So we're going to go off to the left-hand side of that flow chart. Then it says check VSEPR theory or check shape VSEPR theory. And it says cancellation is possible or no cancellation is possible. In this case, we have a tetrahedral, meaning that we have 4 sides. So we do have cancellation being possible. So what we're going to look at is we then follow down a tetrahedral, and now we have 2 other options. Same charge around the outside of the molecule or different charge. Because we have the same charge, this is the tricky one, what we end up with is a nonpolar substance because they all have the same charge. So you don't have to write all have the same charge in yours. You just really need to focus on the non-polar part of that. So that's a tricky one where cancellation comes into play. Last but not least, we'll do CCl3H. So just like we have been doing, we're going to start with our central molecule, which is going to be carbon. Carbon, again, is in group 14, so it's going to have 4 valence electrons. Then we need 3 chlorines. Chlorine is in group 17, therefore it's going to have 7 valence electrons. So there's 1, 2, and then we have our third, and then we also have this little hydrogen. So I'm going to put a hydrogen right up here. Now we need to make everyone happy. So the easiest one to make happy is hydrogen, so we'll just connect those 2. Hydrogen is now happy because it has its 2. And then we need to start satisfying those chlorines. So we're going to bond here, and bond here. So it looks similar to some of the other ones we've done already, but obviously this one is going to have 2 different molecules with the chlorines and the hydrogens. So this time when we do bond types, we're going to have 2 different ones. We have 2 types of bonds because we have a carbon to a hydrogen bond. And we also have, so we only have 1 of those, and we also have 3 carbon to chlorine bonds. So let's start up here with our carbon to hydrogen bonds. When I do that, I need to look at my electronegativity chart, and I see that carbon is going to be a 2.5. Hydrogen is going to be a 2.1. So when I take those, I end up with 0.4. That tells me it's nonpolar. Down here, I also have 3 bonds that are CCl3. In this case, chlorine has the higher number, so I'm going to list it first, which is a 3.0 minus a 2.5. So that's 0.5. That is polar. So I have 3 polar bonds and I have 1 non-polar bond. So what I'm going to highlight here is going to be non-polar. And then in green, that is all going to be polar. So you can see that's different from our last one. So now we have to go ahead and we need to describe the shape. Again, we're looking at our central molecule, which is going to be carbon, and we have to describe the shape. So we know carbon is in there, number 14. Again, we go back to our tetrahedral. And again, I'm getting that from a red reference sheet. So now when I look at the front side that has the flow chart determining the electrical nature, check bond type. At least 1 polar bond is present. Well, yep, that's true. We actually have 3. Then we check our shape. We go down and we have tetrahedral, and it says same charges around the outside or different charges. This time we have different charges because polar, 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 non-polar. So this time overall the substance is going to be polar. So in total, what you guys are going to need are your 2 red reference sheets, the one that talks about electronegativity and has all those values with the bond types that fall into each of those. And then you need the second sheet, which is new for today, that has the shapes on one side with the flow chart, and then on the back side it also has the shapes with the group number of the central atom. It looks like a table. So you need both of those in order to be successful. If you have any questions, let us know. Otherwise, have a great day.